Welcome back to ByteBoardroom. I'm Mincheol. In the last video, we introduced the paradigm shift from prompt engineering to context engineering. We established that to build sophisticated AI agents, we must move beyond simply instructing a model and start architecting its entire information environment. Today, we're rolling up our sleeves and diving into the how. We're going to break down the foundational components that make up a robust context engineering framework. It makes sense to start with the component we all know, which is prompt engineering. While context engineering is much broader, prompt engineering is still the core interface to the LLM. Its foundation was laid by the 2020 GPT-3 paper, which introduced in-context learning. This was the revolutionary idea that you could teach a model a new task just by showing it a few examples in the prompt without any fine-tuning. But the real evolution was chain-of-thought prompting, introduced by Wei et al. In 2022. This showed that by providing examples that include the intermediate reasoning steps, you could dramatically improve an LLM's ability to solve complex problems. This proved that the structure of a prompt could fundamentally change the model's computational path, turning it from a simple instruction into a lightweight form of programming. But a great prompt isn't enough if the model's knowledge is outdated or it's prone to making things up or hallucinating. This brings us to the next major component, Retrieval-Augmented Generation. The landmark 2020 paper by Lewis et al. Proposed a brilliant solution for this. RAG works by connecting the LLM to an external knowledge base, like your company's internal documents or a real-time database. When a query comes in, the system first retrieves relevant documents and then provides them to the LLM as context to generate an answer. This is a massive architectural shift. RAG was the first practical mechanism to decouple the model's reasoning ability from its knowledge base. It transforms the LLM from an opaque, all-knowing black box into a transparent reasoning engine that operates on verifiable, up-to-date information. Now, RAG gives our AI external knowledge, but what about its own history? LLMs are inherently stateless. Each API call is independent, with no memory of past interactions. This is where the crucial idea of conversational memory and state management comes in. Without memory, you can't have a real conversation. Memory architectures are strategies for managing the conversation history within the LLM's limited context window. The challenge here is a direct trade-off between context fidelity and cost. You can't just stuff the entire chat history into every prompt. It would become incredibly expensive and hit token limits. So we use patterns like keeping only the last few turns, or using another LLM call to summarize older parts of the conversation. Effective context engineers must act like economists, constantly managing a token budget to preserve the most important information from the past. Finally, we have what I believe ties it all together: user-centered context and personalization. The best AI systems feel like they know you. They adapt to your needs, your role, and your goals. This concept isn't new. It dates back to the 1970s HCI research on user modeling. In modern AI, the user model isn't a static profile. Instead, it's a dynamic set of information assembled just in time and injected into the context window for each interaction. This could include your role, your project's coding standards, or the business goals of your current task. Providing this user context is what turns a generic tool into a specialized high-performance partner. The performance gains are dramatic, so let's bring it all together. These components aren't separate. A truly advanced AI agent orchestrates them all in real time. For any given task, it uses a prompt to define its goal, It uses memory to understand the immediate history. It uses RAG to pull in relevant factual knowledge, and it uses user context to tailor the response perfectly. This is the art of orchestration that defines modern context engineering. The paradigm has shifted. We've moved from model-centric optimization to context-centric architecture design. The future of AI value creation won't just come from bigger models. It will come from the sophisticated context systems we build around them. For everyone in our field, engineers, data scientists, and business leaders, mastering this discipline is how we will build the next generation of truly intelligent and useful AI. It's how we'll connect our model minds to real boardroom results. Thank you for joining me today. Please like, subscribe, and share this with anyone who is serious about building with AI. I'm Mincheol, and I'll see you next time on ByteBoardroom.